using Horner's EtherNet IP scanner. It's roughly about 10 minutes presentation. If you have any questions, pop them in, we'll get them in the end.
Hello and welcome to today's webinar. In this webinar, we will look at valve control using Horner's EtherNet IP scanner. Here is the agenda for today. First, we will start with a quick review of EtherNet IP. Then, we will discuss which Horner products support EtherNet IP scanner functionality. Then, we will look at the FESTO valve manifold that we will be using in today's webinar. There will be demonstrations throughout, and we will finish with a Q&A session at the end. Let's begin. Ethernet IP is one of the leading industrial protocols in the United States and is widely used in a range of industries. While most often associated with the American automation control company Rockwell Allen Bradley, Ethernet IP is an open protocol based on a much older protocol named ODVA. There are two common device types with Ethernet IP: the I/O scanner, which is the PLC that controls the network, and the I/O adapters, which include any automation devices controlled over the network. Watt Horner controllers support Ethernet IP scanner functionality. This functionality comes standard in the Canvas series controllers and the CPU 300. It simply requires Cscape version 10.2, Service Pack 2, or later, with an extension code required for Service Pack 2 specifically. This extension code is available through tech support. Your controllers also require firmware version 17.4 or later. In the XL Prime series, this comes as a licensed feature. For a one-time upgrade fee, you can add this functionality to any of your XL Prime controllers. You will also require Cscape 10 Service Pack 3 or later, and controller firmware 17.5 or later. Next, for today's demonstration, we'll be using this FESTO VTUX valve manifold. It's designed to integrate pneumatic and electrical components, such as valve manifolds and sensors, into automation networks. It's perfect for today's webinar as it uses an Ethernet-based AP backplane. This real-time backplane supports high bandwidth and shorter cycle times. This is the valve manifold we have chosen to use, but the workflow we showcase today should work with any valve manifold on the market today. And that's all of the preliminary information covered for today. Let's now move to Cscape and start on the demonstrations. Here we are in Cscape 10, and to start, we're going to show you how to connect a valve bank to Cscape 10. First, navigate to Hardware Configuration. Here, we have the Canvas 7 controller that we will be using today, and we are going to set up our network on LAN 1. So, we click on LAN 1. If this is your first time setting up a network, you will need to configure the IP address and net mask fields here. But for the sake of this demonstration, we have already set this up. With your network configured, navigate under Resident Protocols to Ethernet IP Scanner and check the box to enable it. Then, with it highlighted, click on Configure Selected Protocol. Here, we must assign a disable variable, which will allow us to enable and disable the network. We also need a status variable, which will return information about the network. Since these didn't exist before, Cscape will automatically create these once we hit OK. Next, we can start adding adapters. And let's begin with the most crucial one for today's demonstration, the valve bank. Right-click on the Ethernet IP scanner options and click Add Adapter. Here, we can start configuring the valve bank. First, we assign a name, and we will go with valve bank. Then, we assign its IP address. We are going to type in the exact value, but this can also be a variable if needed. Then, connection timeout. This can be any value you want, but we have chosen 100 milliseconds, which should work for most cases. Finally, we need to assign a disable and a status variables. We have not created these variables ahead of time, so we will type in their names here, and they will be created automatically once we close this menu. With that complete, we're going to go back up in our list and add an EDS file. Here, we have some EDS files, and we're going to select the correct one for this valve bank. Cscape will ask us to confirm, and we'll click Yes. Now, we have a new option. Here, under Connections, we have a drop-down list of different connections. For this demonstration, we will use the default configuration, but Any of these would be valid for different applications. With that selected, we've now done everything we need to set up the valve bank. From here, we could navigate back to the previous menu and start adding any other adapters on our network. However, to save time in this demonstration, we have already configured our network and all the devices on it. Here we have our completed network, with all our devices connected. Let's take a look at the finished configuration for this valve bank. As shown, we elected to use the default connection in the EDS file. Then, when it comes to input, we selected integers as our data type. These are the most convenient data type to use when working inside a Horner-controlled network. The data length was automatically set to 8, and we set the RPI to 50 milliseconds, as that works best for our application. Finally, we assigned a local variable array to receive in all these input variables. Our output tab looks identical. Once again, we chose integers as our data type with a length of 8 and an RPI of 50, along with another variable array to store all these outputs. Next, let's look at the variable handling for the valve bank. Here we have the two variable arrays from the valve bank. For this demonstration, we are only concerned with the output data, or the data that will control the valves. By default, this variable has 8 words of data, which we have mapped to a single 8-word array variable. Then, to work with individual variables inside this array, we've created Boolean variables that are assigned to specific bits inside the array. Here, we have the individual Booleans that are each mapped to different bits within the data. As you can see, we have done this by mapping each of them to the correct register number. Our first bit in the big bank of data is mapped to OR2101.1, and this controls the first valve. Then, for the second valve, it actually requires 2 bits to control it correctly. So, we have mapped 2 individual bits at the correct locations. This is how we handle variable data for the valve bank in Cscape 10. Finally, let's look at our ladder logic. Here, we have our first cylinder with only 1 bit and our second cylinder with 2 bits. Cylinder 1 is connected to a cylinder with a spring return. Turning on the first bit will cause it to extend, and turning off the same bit will cause it to retract. The second bit is not used. Then, at the end, we have our status variable, which will return the current status of our cylinder. Then we have cylinder 2, which requires both bits for control. Turning on the first bit will cause it to extend, and turning on the second bit will cause it to retract. We also have 2 status variables here that will tell us the current status of our cylinder. And with that covered, let's now move on to the bench and demonstrate how this works at runtime. Here we are on the bench, and here on our screen is an image of our valve bank. We have 2 valves, each with 2 bits. Then, over here, we have valve 1, which is connected to cylinder 1, and valve 2, which is connected to cylinder 2. Valve 1 features a spring return, so it only requires 1 bit to control, whereas for valve 2, we need to control both bits to manage extending and retracting the cylinder. So, let's see if our configuration works. We will press this button for cylinder 1, and as you can see, it has extended. Here, we can see our status variable has turned green, and when we hit the button again, our cylinder will retract, and our status variable will return to being red. Cylinder 1 is working as intended, and without any issues. Now, for cylinder 2, if we look over here, the status variables are currently telling us that it is retracted. If we hit the extend button, you can see those bits swap, and if we then hit retract, it'll return to its original state. Cylinder 2 is also working as intended. That is everything you need to know to set up valve control using Horner's EtherNet IP scanner. And that concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, so we'll have no webinar next week because we will be at SPS Italia, but we will be back the week after. so the registration links will be up for those. I don't see any questions in as yet, but if you do have any, feel free to get in contact with tech support and we'll help you out there. Okay, thank you all for joining, and we'll see you next time.